What we have here is three variables, x, y, z, and a single equation describing them, x minus 2y plus 5z equals 1. And if you're a little bit familiar with these types of equations, you probably know that there are many, many ways that we could actually solve something like this. And one of the ways to actually show this really clearly is if I just rearrange the equation and say solve for x, I would be able to write x equals 1 plus 2y minus 5z. And in this situation, what we can see is that I can choose literally anything that I want, any real numbers for y and z. And as long as I set x equal to this 1 plus 2y minus 5z, I'm going to have a solution to this system of equations. So what I'm saying here is that I have the freedom of choice for my y and z variable. So I'm going to call them free variables. And that's a word that you'll see thrown around a lot in any videos or notes that you read for linear algebra. So y and z are free. And technically, I could also say x is free, but I have to be careful when I use this language because I choose a set of them to be free. Because if I say y and z are free, that means that I can choose anything I want for them. But once I choose those, x is no longer free because x has to satisfy this relationship here. So once I choose y and z, x is no longer free. So I would say that y and z are free variables, and that fixes x. So alternatively, I could rearrange it and solve differently. But for the way that I'm structuring this, I'm going to say y and z are free, and they determine x. Now, when we have free variables, we usually don't want to describe our solution in terms of them. Usually what we're going to do instead is introduce a couple of new variables that we'll call parameters. So what I'm going to do is let y equal t, and I'm going to let z equal r. Usually in the notes, you'll see s, t, and r, like those are typically the three letters that you'll see used. I personally will avoid s a lot because my 5s and s's sometimes tend to look very similar to each other. So I usually do stick with t and r. But yeah, once I have those, what I'm going to now do is just rewrite this equation here by substituting y equals t in, just making that switch, and making this switch here for r. And that allows me to rewrite x equals 1 plus 2t minus 5r. And then I'm going to write out the whole solution just so it all looks nice and packaged together. Then I'll also have y equals t, and I'll also have z equals r. And basically, yeah, this is our parameterized solution of this, and we can generate as many solutions as we want by just choosing different values of t and r and plugging them in. So if, for example, I would get the solution 1, 0, 0 by just plugging in t is 0 and r is 0. I could plug in t is 1 and r is 3 and get a whole different solution, and they'll all be different solutions, literally any choice of t and r here. I could have, again, written this differently. I did say before x could be free. We could alternatively find a solution, and I'm not going to finish it, but we could do something like, say here, 5z equals 1 minus x plus 2y. And so z equals 1/5 of 1 minus x plus 2y. And then now in this structure, my x and my y are free. And z depends on them. Alternatively, we could have just solved for y. So I'm not going to finish this solution up, but we can do the same thing. It doesn't really matter which variables you choose as long as the structure is okay and you recognize that one of them will depend on the others. So you can't just say they're all free because they all can be anything. There is a strict relationship between them.